go through the solutions and highlight a couple things. A few things I saw, I kind of throw this question in thinking, oh, here's a way they can get a few points. I thought some people might get stuck on the solving, but I thought, oh, well, most people go to... The thing that kind of surprised me on this one was how many people did a long calculation. They wrote stuff all over the place and did a whole bunch of stuff here, and I was like, whoa, what is going on? I didn't expect that. So I did not mean this to be a big calculation problem. I meant take the derivative, do the dot product, when is it equal to 0? So I think maybe people forgot that vectors are perpendicular if their dot product is 0. Not sure. But the other thing I saw was the tangential component of acceleration is the dot product. So I didn't think anyone would calculate that. I thought you would all just say 0. But most people didn't see that. And so this ended up taking more time. But that's part of the exam. If you do something in a not efficient way and it takes more time, that's kind of on you. So anyways, this should have been 0. So if you gave some complicated expression, there was a small deduction for not recognizing it was 0. But that's it. The other thing else was small. And then I also thought this was, I was trying to just say, because a lot of times people say these ones with implicit are hard. Why is that the only question? So I thought, okay, I'll just give a straight derivative question. I'll throw in this one thing from the homework. And most people did get that. A few people forgot that piece. But really what got people was this and the product rule. And that's another thing that surprised me. So there were two things on page 1 that surprised me. And that's why I think the exam took longer than I thought for when I was, proctoring and watching students. I was like, why is this taking longer? Because some people ate up time here and ate up time here. So I wasn't expecting that. But again, when you're doing the derivative with respect to x, you have to think, okay, the derivative of sine is cosine. Now I need to do the derivative of the inside with respect to x. And the rule is to bring down the coefficients, take the derivative. Those two things should have been out in front. So there should have been a y squared. A lot of people didn't have a y squared. So there were various, I say a lot of people, 70% of the class had this completely right. But these were the things for the people that got really low scores. These were the things that kind of build up. You got to get all these points. The next problem, people did well on this. I have this on the many old exams. It's very common, final exam question. So you had to realize, okay, the two variables are here. We need to take a derivative, right? So we're thinking of z as a function of y. I did quite a bit of this. So when you take the derivative, you need to use the chain rule, which means you need to take the derivative of the inside, which is what dz dy is. We usually don't put the y in there, but that's what we're thinking of it as a function of y. Then you just have to plug in your numbers and see what you get. So the scores on that were very good on this page, but a lot of people miss like a point or two in the middle, maybe a point at the first part. So anyways, probably, again, you will see some of those things on the final, not necessarily exactly like that. Definitely partial derivatives are pretty popular like this. So if you missed that or got very few points on this, you'll want to study that for the final. The next question was about finding critical points. And people did well on this, but it's about organizing, right? You had to take the parts with respect to x, you had to take the parts with respect to y, and then combine. In my opinion, it's easier to start with the second one because it's already factored. So I would have done this. I would have said one possibility is x is 0, one possibility is sine of y is 0. And that gives two possibilities. The sine can be 0 many, many times. Maybe that scared people a little bit. But the first times are 0 and pi, and that's why I said this, to try to minimize what you had to check. So ultimately you had this little bit of a tree. So then you plug in 0 to the first one, you get cosine of y is 0, and the only solution when cosine is 0 is pi over 2. Those of you that put the unit circle on your note sheet were probably happy right here. Okay, when you plug in 0 here, you get 8, so x has to be 4. So the people that aren't organized in their thinking lost points here, meaning they lost track of things. So I want to encourage you to use this method. Then you had to take the second partials. You get a couple local maxes. I was going to show a visual, but this video is going to be long enough as is. If you encounter a question like this one, your job first and foremost is to label. So remember, these are your tick marks. So your very first thought is, I need to put a tick mark at y equals 0 and a tick mark at 12. Your second thought is, I need to graph these two things, this and this, and it would be good to write them this way. That's y equals 3x, so this has to be y equals 3x because it's steeper. And I originally wasn't going to include a picture, but then I decided at the last minute to include one, which I think I'm glad I did. And there's y equals 2x. And then you would have said, okay, I need to only go up to 12. So how do I do that? So I would have thought, okay, when y is 12, x has to be 6. So you really needed to label these things, right? Label this 4, label this 6. And then it was, okay, from 0 to 4, you're between blue and red. And from 4 to 6, you're between blue, and I shouldn't use blue again. You're between blue and orange. That's what you need to say. From 0 to 4, you're between blue and this red or whatever I'm using. I guess that's not red. And then you are from 4 to 6, you're between blue and orange. I know it was 2 regions, but that's not uncommon if you look at my old exams for that. Okay, then we had sort of a straight calculation given a region. So step 1, find your z's. Step 2, draw the region. So again, most people are getting this. The people are getting low scores don't know this. So you needed to draw this. You need to draw this. You might say, well, how did I know the other side? It said first octant. And there was a setup. Most people did the setup correctly. A few people messed that up. There were lots of small calculation errors. Some people calculated this way, but when they calculated with respect to y, they didn't know that the integral was going to be x squared y. That was a common mistake. This one, there were various calculation mistakes. One somewhat common error was not solving this correctly, or just assuming it was pi over 6 or pi over 2. But this was really a question about conversion, but you didn't have to do as much converting. And when you're trying to find when two polar curves meet, it's nice to work directly with them. So you need to know when cosine of 3 theta was this, which there are a ton of solutions to this, but the first one is when this is pi over 3. So you had to say, when is cosine a half? Again, would have been nice to have that unit circle. And then you say, oh, theta has to be pi over 9. Maybe some people thought pi over 9, that can't be it. I don't know. And then as you're walking out, this here is this circle, r equals 1, and this is the actual loop. Okay, the rest of this went fairly straightforward. There were very small mistakes and you losing a number in calculation, but it came out fairly nice. I tried to it's hard to make the numbers perfect, but that's what we got. Okay, so then the last question was an absolute max or min. Just a comment on this, because there's always people that ask for regrades on this one. And so I want to make it clear. I tried to say this in class as well. This is about a process. So we don't just look at the final answer. There are people that got the correct final answer and lost points. Because we weren't just grading those, we were seeing if you checked all the right things. And that's why I tried to say this very clearly. The things we looked for: 1, is this somewhere on your page? 2, is this somewhere on your page? Or this. You could do it either way. And I wrote up solutions with both. So both of those, so if you did that and this, or that, and you did this correctly, you had 6 points. If it is impossible for us to easily find this, or this, or this, you lost a whole bunch of points. Okay, so I itemized that a lot, but this is basically saying, okay, these are the things we have to consider. Now, 0, -4 is not in your region. A lot of people included that, but 0, -4 is not in this region. Okay, step 2, you were given this function. There are 3 things you have to check if you're considering this side. First, you have to check if the function itself has any critical numbers, and it does at x equals 0. And there are two endpoints, right here and right here. So these three things had to be computed. A few people just plugged in 0 and got 5 and did not plug in the endpoints. Again, they might have gotten the right final answer, but they're going to lose a couple points for not checking everything. So when you look at your work and you're mad about the partial credit, double check. Is there 55 on your page twice? Is there a 5? Okay, those things need to be there. Is that function clearly visible? Okay, and then when you did it with, if you chose to do it with respect to y, then the endpoints are 0 to 5. So that's a little bit subtle. The reason those are the endpoints is because that's the smallest y can be, and the biggest y can be on this side. So ultimately, a lot of people didn't plug in this 5, didn't plug in this endpoint. So if there's no 70 on your page anywhere, then there was some deduction, even though you might have had the final answer right. If you do it this other way and solve, the derivative is a little bit harder to handle, and it was really easy to lose a solution if you did it this way, because a lot of people went to solve this and they forgot, oh, x equals 0 is a solution. And so I do need to check that. So no matter how you did it, whether you did it this way or this way, one challenge was, oh, I do have to consider this point. When you did it with respect to x was a critical number. When you did it with respect to y, it was an endpoint. But either way, these points had to all be plugged in. So 1, 2, 3. There were 6 things we had to see. 1, 2, 3. This is actually a repeat. 4, 5. Oh, this is the same because when you plug in plus or minus 3, so 6 is here. But if there was no, first we looked for the functions. Did you get the functions? And then we looked for those numbers. So if you didn't have a 70 or if you didn't have a 55, you didn't have a 5. Some people just randomly checked endpoints and got some of the points, but those people lost a lot of credit because the bigger thing was understanding the functions you had to analyze. Okay, that's it. Hope this helps.